All right, welcome to Gene Bites, everybody. I'm Dr. Chrissie from NGI, and I have my team with me today. I've got Michelle Godfrey and Laura Kelly and Samantha Menz. Happy Valentine's Day and happy Heart Healthy February. So today we're going to talk to you guys a little bit about particle testing and HDL and LDL, and we're going to go through a particle test. So if you guys give us just a second, we're going to go ahead and get our presentation started for you. Well, all right. So since it's Valentine's Day, the question of does size really matter after all? Since we're a team of ladies here, it's always a fun question. But of course, we're joking. We're talking about particle size in terms of cholesterol. So let's go ahead and get started. The first thing we want to do is kind of go over what atherosclerosis actually is. There's a lot of misconception about that. Most people think, oh, okay, I'm going to eat, eggs, and that's going to cause me to get, heart disease. So let's really talk about that to start out with. So what actually ends up happening is that things like smoking or toxins or diseases like diabetes or immune dysfunction can end up causing injury to the vascular system, okay? And so this causes repeated injury over and over again, all right? So this ends up causing the immune system to have a response, okay? And so this causes a migration of a certain type of white blood cell to the area, certain things called monocytes and macrophages for our physicians or for our clinicians out there. And so this causes your bad cholesterol, your LDL, to become oxidized, okay? And this repair process results in the plaque or the fatty streaks that we hear about so much. And so sometimes we call these things foam cells, all right? And so this is actually what is occurring. So it's not actually so much that we have fat rolling around in our system all the time. It's actually this repair process that's causing the atherosclerosis or causing the heart disease. And so this can mostly be caused by, again, toxins and immune dysfunction and sometimes hypertension, radiation, these types of things. So there are a lot of different things when we start thinking about heart disease that we need to be taking into consideration instead of just thinking about, oh my gosh, is it eggs or is it the steak I ate? Diet does, of course, play a big role into whether or not you're going to have heart disease, but genetics, environment, all these other things also play a pretty big role in whether or not you're going to have atherosclerosis. All right, so what we're going to do is we're going to go through some of the basic lipid markers that you would find on a standard cholesterol test, and then we're going to talk about maybe why we should look at some other types of testing. So I'm going to let some of my team members go through these basic tests, and these types of tests do require fasting, just in case you are curious and doing these types of tests. So I think we're going to have Laura go through these tests. Yeah.
So the basic test that everybody kind of knows about is the total cholesterol. So we're looking at cholesterol, which is basically sterile, and it's essential to membrane structure and the precursor to all sorts of different types of hormones, as well as bile and vitamin D. But the big message take home here is that cholesterol itself does not necessarily cause that hardening of the arteries that we were just talking about. And so what actually happens when we're looking at the different types of cholesterol, which we'll talk about today, or the different sizes of cholesterol, is if you have really large, fluffy cholesterol, it's not going to get lodged into the walls of the arteries. So it's really more about the size and those smaller little pieces of cholesterol that are going to get trapped in there. So standard cholesterol tests don't look at that. They're not looking at those different sizes, which is why we're talking about size today. And so they only really are predictive of about 40% of heart attack and stroke risk. So then the other thing that we look at, of course, is triglycerides, which everybody's heard about, but triglycerides are much more associated with insulin and carbohydrate intake than things like eggs and other types of saturated fat. So today what we're really looking at again is how cholesterol causes that inflammatory process. And it's not necessarily all about how much cholesterol you have, but what size the little particles are. So back to size matters.
Yes, size definitely matters. All right. I think let's have, Sam, let's have you talk about this for a second here.
Sure. So you can't really talk about cholesterol without talking about lipoproteins. If you break down the word, it's literally fat and protein. That's what it's made of. And so cholesterol and fat are hydrophobic molecules, meaning that they're not going to be able to just float around freely in fluid, in our blood, in our bodies. So the lipoproteins are essential to transporting fat and cholesterol throughout the body. And so, of course, we've heard of our high-density lipoproteins, or our HDL, coined the good cholesterol, and then our low-density lipoproteins, or the bad cholesterol. So I'm going to take on the bad one first, and then I'm going to let Michelle talk a little bit about the good one. And I use quotations. So LDL's gotten a bad rap, and that's mostly because it transports cholesterol directly to the arteries. And if this is not controlled, it can form plaque, and that's what can really lead to an increased risk of heart disease. There's a couple different genes that can modulate your LDL, how it acts in your body, your risk for heart disease based upon your LDL. One of those is LPA, which is a significant heart disease risk marker. What this does is it can promote the uptake of LDL into the blood vessel walls, and at the same time, it can also inhibit the enzymes that dissolve clots. So it's kind of a double whammy in terms of more LDL is accumulating, and then it's also not dissolving the clots that form. So obviously that can create a big problem. So I'm going to let Michelle talk a little bit about the HDL and some of the genes that help to modulate that.
Sure. So I did a gene bite last week on HDL. So if you want to go back and listen to that, I talked a lot about why it can be high, but there's a gene called APOA1 that can actually affect your HDL and make it low. And the reason we call HDL good is because it's actually carrying the cholesterol back to the liver. So it's reverse transport, and our liver is then going to make bile or excrete it from the body. So that's why it's considered good. But as I talked about, it can actually be too high, and then your liver is working harder, and your liver is doing a million other things. So if you have too much cholesterol in the liver, then you're going to have problems there too. So it's APOA1 that we'll look at for you. And if you have variation there, then that can make your HDL lower, and a lot of times make your particles smaller, which is not good.
Yeah, absolutely. So just to keep in mind here, if you are doing this type of testing, you do have to fast for these labs. A lot of times people go, oh, it's fine just to go ahead and do your cholesterol test and you don't need to be fasting, but these tests do require fasting. And so, as we mentioned here, a lot of people do say, gosh, it's good to have your cholesterol, your HDL level good as high as you possibly can. This is not a right thing to say, or not, it's a fallacy here. And so, we get this question a lot, well, why is that? As Michelle said, your liver's doing a million other things. It's your major detoxification organ. And so when you're thinking about this reverse cholesterol transport, you're thinking about, well, HDL is essentially, it's a lipoprotein. It's a fat protein, or a protein carrying fat. It's literally taking the cholesterol from your body and taking it back to the liver for processing, to get rid of it. And if you have high amounts of that and you're bringing it back to the liver, and your liver can't really process that, or it has other things to do, you think that maybe the liver might then get congested with fat, and then we might have fatty liver disease in that process. So fatty liver disease is pretty hard to measure because, if we're looking at, liver markers like ALT or AST or GGT, these might be mildly elevated, but not anything extraordinary. But, you would really actually have to look at something like an ultrasound to be able to see whether or not, or a CT scan, to see whether or not you have these little hypodensities or little tiny cysts of fat globules in your liver. So, this is something that causes a dysfunction in our body when we have high levels of anything. So, like we teach just as much in pretty much any functional medicine model, we want to have a functional range. So we want to have a good range of HDL. We don't want it to be, the Goldilocks phenomenon, not too high, not too low, but just right. So, Michelle, what do you think is the perfect range for HDL?
We recommend around 55 to 70. So anything higher than that is not great. Good,
I agree. All right. Okay, so I think we already touched on apolipoproteins. So, the big ones that are out there, ApoE is almost a celebrity apolipoprotein. Pretty much everyone knows about ApoE, mostly because of Alzheimer's disease, but other big ones are ApoB, ApoA, ApoC, and lipoprotein little a. We always kind of ask, is there a SNP for that? And of course, there are SNPs for all of these. So these are the things that we look at on panels like our CardioDX. But these again are they're proteins that bind lipids to form lipoproteins, okay, and they transport these things through our lymphatic and circulatory systems. So really, really important to look at the function of these things, because these are the genes, these are the ones that determine whether or not you can carry fats and whether or not you should be consuming things like saturated fats. So it's not actually cholesterol, again, that's the bad guy, guys. It's the functions of these lipoproteins and these apolipoproteins. So that's what's really important to look at. So if you get a recommendation from, someone like us here at NGI that says, you should be consuming a saturated fat recommendation that says, you should eat, 25 grams or less of saturated fat per day, it's likely because you have a variant or several variants in these. Because there's, requirement for that, because your body literally can't transport some of these fats. So there are other ways to tweak some of these apolipoproteins. Sometimes it's olive oil or fish oil or, certain other herbals, exercise, those types of things as well. But, we have to be very careful not to overload a lipoprotein that is essentially broken, because the way it gets stuck in the body, if it can't transport, if it's broken, it's literally going to, lodge in your artery or in your brain if it's ApoE4.
I think that's a really important distinction, by the way, for patients, because a lot of times they're thinking more about the total amount than the fact that it's about almost like a transport, the way in which fat is moving around the body, that it's more complicated than just the total amount of fat that you're eating and when it becomes inflammatory. When I talk about that, it definitely sort of is like, oh, I didn't really realize that was what the issue was. So.
Well, yeah, and there are other inflammatory markers that we look at. So things like myeloperoxidase or LPPLA2, C-reactive protein, homocysteine levels, all of those things that we look at on things like the CardioDX that most practices are not looking at. So, we're actually trying to assay and measure the amount of inflammation, lipid peroxides, all of those things. We're looking to see whether or not there's actually inflammation occurring in the artery itself or in the cardiovascular system itself as a result of these things. And so we can actually track and see whether or not the interventions are decreasing that inflammation. So, as we look at particle numbers, and then that's why we don't just look at the standard 40%. 40% is not acceptable. We are targeting a much higher efficacy rate.
And also remember, if you're doing doing something like a ketogenic diet, you really need to be monitoring this stuff, because you can change your levels sometimes for the good and sometimes for the bad. And people will say, well, it doesn't matter if your cholesterol is going up because of this diet. And it might not matter. It might be okay. But if you're not looking at each one of these individual markers and your size and your inflammation markers, then you're not really looking at the full picture, and it may not be the best diet for you, even if you're losing some weight or feeling better at first. If you do this for a long period of time, these markers can actually go in the wrong direction.
That's absolutely correct. And on top of that, looking at like your metabolomics in terms of mitochondrial function for that, for the ketogenic diet. You know, we may not jump into peroxisome function today, but that is another thing that we absolutely look at, another gene that we look at for the ketogenic diet. There are several genes that we look at in terms of function for whether or not a ketogenic diet would be appropriate. Several to do with fatty acid oxidation, you know, delta-6 and delta-5 desaturase, elongase, all of those types of things that we look at on the optimal diet panel.
And this is why, too, you see that swing with research, right?
Mm-hmm.
So the swing where it's like, oh, eggs are good for you, butter is good for you. Oh, wait, no, it's not. And it's, you know, again, it's because they're not controlling for, you know, the genetics and the individual biochemistry, but it confuses people pretty significantly.
Massively. And I think that's one of the reasons why, as we come into the era of precision medicine, that the randomized controlled trial really does need to step out of being the gold standard, because we really cannot use that in terms of broad population-based studies when, you know, everyone really has their unique biochemistry, their unique collection of genetics and metabolomics. So, you know, I think there will be the rise of the N of 1 studies when we have these massive AI supercomputers that can compute that data. But, you know, I mean, as you guys know, that, you know, that's an incredibly expensive process. And, you know, as we aggregate that type of data, it's an incredible process. So, but one day, soon, hopefully, for all of us. All right, so again, to drive home the point, especially for patients, why is it necessary to have this particle breakdown if it hasn't been made crystal clear so far? So, you know, not everybody is going to have, you know, this, you know, massive spike in LDL or high levels of total cholesterol. And so, you know, this is something that we do see with patients, you know, so you may have that athlete, you may have that person that is out there and their cholesterol levels are 175, and then all of a sudden they drop dead of a heart attack and they go, oh my gosh, you know, we just weren't expecting this. Well, it's because they weren't looking at their particle breakdown, okay? So please, 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 pretty please, everybody, do not have the, you know, this, you know, false sense of security that, you know, you go to your regular doc, they run your cholesterol panel, they go, man, your cholesterol levels, they look great. Please don't take that as an okay. Please get a cholesterol panel test or a particle test. They're not that expensive. You know, we can get them through LabCorp for $40, $50, and that's at cost. Your insurance will cover this, I promise. It's not that expensive.
And also don't forget, they're also going to say, oh, you're fine because your HDL is high, even if your cholesterol is a little high, now you're protected. But remember, as I talked about last week, there's a gene that makes your HDL artificially high, and you're not as protected as you seem. So just remember, you got to look at all the pieces parts.
Yes, absolutely. So CETP, if you are not looking at your genetics, please don't assume that your HDL levels are normal or high or protective. There, you know, I don't remember the population frequency on CETP, but you know, several people, like when we look at our panels, I would say that I would almost say that most people have a minor variation in CETP. And I don't know, Michelle, what would you say? At least maybe 25, 33% of people have at least the causative variant for CETP?
I would agree.
So, you know, we're, you know, and we can go and pull that data and put it into the comment boxes if somebody would like it. But the RS number starts with 1008 something or other.
0075.
There we go. Thank you, Michelle. So, you know, if you guys are interested in that, we'll be happy to pull that data. So the problem here with particles is that we're looking at numbers and we're looking at density, okay? So this is why it's really important, okay? So you may not have a total number issue, but when we actually break them down, we want large, fat, and fluffy particles, okay? So, you know, this is something that people go, wow, that sounds kind of weird. You know, you're nutrition people, why are we talking about fat and fluffy things? Well, we don't want small, dense, hard little pieces of cholesterol, because if they're hard and dense, that means that they're going to burrow into your artery systems, okay? If they are fat and fluffy, they're happy, they're floating around in your system, they have no interest in getting into your arteries. They're basically going to bond with the fiber. Happy Valentine's Day, and you are going to eliminate them, and you're not going to have any more issues with them. Okay, you're going to go and have your morning coffee, and then they're going to go bye bye. Okay, so this is going to be a good thing for the fat and fluffy particles. If they're hard and dense, they're staying around. Okay, kind of like, you know, I don't know, the old boyfriend from high school or something. It's not going to be good. All right, so that's not what you want. All right, so we want large, fat, and fluffy particles, like your favorite cat. Okay. All right. So what we're going to do here is we're going to go over a test. Okay. And so in full disclosure, this is actually me. This was me several months ago. So you guys can see I've been on a journey here to lower my particle numbers. My particle numbers look better now, which is good. But we're gonna go through this because we can't put other people's data up here. But you'll see here that my LDL particle number was 1,074. So this flagged as red, is just in the moderate level, but it's just barely out of range here, okay? And then we're looking at the LDL. This is always a calculated number here when you do the NMR profile or the particle test, okay? This is also just barely squeaking out of range at 109, but it's gonna flag as high on a test. So they basically give you a number up at the top of the test, and then they give you these pretty graphs at the bottom, which are a lot easier to read. So you'll see here that my triglycerides functionally were a little bit higher. Usually we like them to be about under 100. But I do eat carbohydrates, so that's a thing. For me, I'm definitely not a ketogenic person. So they're at 110, but you'll see here my total cholesterol was 182. So that would have been great. And my HDL was at 51, but okay, so this would have been my total normal cholesterol, okay, panel that I would have gotten just looking at a regular screening. So total cholesterol 182, triglycerides 110, and HDL 51. So they would have gone perfect. You have protective HDL, your triglycerides look great, and your total cholesterol is 182, all in the green. No risk factors for cardiovascular disease. Now, I have family history of cardiovascular disease, and I do what I do, and I went, not happy with this, I'm gonna run this panel. So, coming over here, HDL particle size in the 50th percentile at 30.4, okay? So, not super excited about this. Now, my small LDLs, okay, so these look pretty good, okay? So I have a little kitty cat coming to join me over here for our gene bite today. So my small LDL particles, these look pretty good, okay? So they're in like the 25th or 26th percentile over here. So pretty happy with that. This basically puts me still in the large pattern A, which is the protective pattern, okay? But it's kind of down here on this side. It would be better if it were up here. And that's mostly because this HDL particle size is in the 50th percentile. So when we come down here and we look at the rest of the pattern, so the large VLDLs, you know, looking at the 35th percentile. The small LDLs, again, look good. The large LDLs, those are dropping down. They're pretty low, okay? VLDL looks great. LDL size is good. That HDL size, man, they're small. They're definitely in the red. Okay, the insulin resistance score looks, it's okay. It could be better, okay? Team, what's wrong with me? What gene do I have? What is my defect?
You have ApoA1.
Okay, you're right. I do have ApoA1. What should I have done, or what did I do? what should I do? So if this was a new client, and you were looking at this, what would you tell them to do?
Exercise, some extra olive oil, possibly low saturated fat. We'd look at some other things first.
Okay.
What else do we have on that list? Help me, girls. Mind blank.
What would you?
Fish oil.
Fish oil. Yep, fish oil.
Okay. So what if am I a fish oil responder? Does that matter?
Fish oil response is we usually look at that in our diet panel to see if it will lower your triglycerides. But for HDL, it's actually going to be helpful.
Okay. All right. So, all right. And so I actually am a fish oil responder. So I did start taking fish oil, and I have been exercising. My triglycerides are now in the 80s, which is a good thing. And I haven't run a new panel yet, but I'm planning on doing so next month. So we'll come back and see if my HDL size has improved, but I expect that it has. So the ApoA1 is basically associated with what?
Low HDL and high small HDL particles.
And hypercholesterolemia.
Hypercholesterolemia, right. So basically genetically high cholesterol. So is that gene expressing for me?
It is expressing.
Well, sort of.
Yeah.
Right? Because my total cholesterol is not high, right? So like in certain family members in history, it totally expressed because they ate, like McDonald's and that kind of stuff, and had heart disease. So, but for me, my total cholesterol is not high. But the HDL issue is still problematic, even though the total is fine, right? So it would never have been flagged in traditional medical model. But looking at the particle size, I'm like, oh, we Houston, we have a problem. So to really be protected and not have heart disease, I'm working aggressively to get these fat, fluffy particles instead of having these small HDL particles, so that when they go to my liver, they don't get stuck. Yeah, so fish oil, olive oil, exercise, and really working on changing the ratio so that my HDL then matches my LDL.
And your HDL is, obviously moving through the liver, so liver health would also be too. So even things like alcohol
and I quit drinking. Right. I gave up alcohol. So these are some of the things that are very, very helpful in terms of managing your overall cardiovascular health. So for our listeners, this is for a lot of people, that's a really big shift. Exercising every day, not drinking alcohol, all of those things. But they can make a pretty dramatic impact on your overall risk factors for cardiovascular health. So, food for thought. All right, so since it's Valentine's Day, we have another Gene Bite coming up. We're going to release this roundtable today, and then Samantha has a Gene Bite coming out today as well. We'll probably release that. We'll probably release that tomorrow on LDL, so that'll be coming out. And then Laura has a Gene Bite that'll come out next week on this beautiful pathway over here. So I'm going to let Laura talk a little bit about what's coming up next.
Right. So cholesterol feeds into our hormone system. So I'm going to be talking a little bit about sex hormones and stress hormones, and how basically stress can really tank your sex life. So so this pathway we'll go through a little bit, talking about how cortisol impacts aldosterone and estrogen and testosterone and progesterone, and then also how it can cause high blood pressure. So also leading to, cardiometabolic disease as well.
So yeah, so don't forget that our favorite friend cholesterol over here impacts not only hypertension and hypotension for some people as well, but that basically stress, so cortisol is the great amplifier here. But you know, stress and cholesterol basically can zap your sex life. Speaking of Valentine's Day, guys, hopefully everybody has a nice and peaceful day and wonderful Valentine's Day. But if you have questions or issues with that, then come learn about that next week from our Gene Bite. All right, and so of course we are having a sale this month on cardiovascular testing. So we have our Cardio DX. We look at, I believe, 100 and Michelle, how many SNPs are on there?
Put me on the spot. I don't remember this one.
Of course. Okay. So
it's under 100, but it's a lot. It's a lot of genes.
Lot of genes. So I think there's 175 genes that we assay, or SNPs that we assay on our Cardio DX, and we are offering a free particle test with this panel this month. So if you have any questions, please put them in the comment box, and of course visit us at nutritionalgenomicsinstitute.com. Thank you for visiting us today on our roundtable Gene Bite, and we look forward to seeing you guys next week. Take care, and we will see you guys soon. Bye. Bye, guys. Happy Valentine's Day.